Yeah. So, oh, what happened? Yeah, so this is the question number 12.3, right? So we are solving the capacitance of different capacitors, right? So these questions we'll do quickly, and then we'll move on to the next one, right? So let us quickly do all these questions. We'll do only a few questions, and then we will. So this is the question on Wheatstone bridge, right? So five capacitors of capacitance 10 microfarad each are connected with each other. So yeah, so we will start, right? We'll start with, let's say, A point. So this is A, right? And then this is B point, right? So this is the capacitor, and this is the B point, right? And then again with A, it is going to D. So this is the D point, right? So this is D point, and D is again going to B, right? So D is again going to B. So this is C3, right? This is C4. This is C1. And then from B, it is going to this C point, right? So from B, it is going to this C point, right? So this is C point. And then from D as well. So from D as well, it is going to this C point. So now it is completed, right? Clear?
Yes, sir.
So we start with this point, right? So we start with, so we have to calculate the capacitance from A to C, right? Yeah, so we have to calculate the capacitance from A to C. And we know that, right? We know that in series, what do we have? In series, 1 by C is 1 by C1 plus 1 by C2 and so on. And in parallel, this is simply C1, C2 and C3, right? So this is parallel and this is series, right?
Yes.
Okay, so now if we have to come from this point to this point, right? So if we are here, right? If we are B to C and D to C, so these two, right? These two are in parallel. Or we know that this is a Wheatstone bridge, so this part is discarded, right? So
Yes.
this C4 and this C5, this C4 and C5, this is in series. So this would be,
Mm.
the total would be, and this is 10 microfarad, right? So that would be 1 by 10, 1 by 10, and that is 1 by C. So that would be 1 by C would be 2 by 10. So that would be C would be 5 microfarad. So this is 5 microfarad, right? And the downward that would also be 5 microfarad, right? Right.
Yes. So the answer will be
And
10.
yeah, so the answer would be 10 and yeah, so the answer would be 10 micro, right? So this is the answer for this question, and now you already know, so no need to solve this question, right?
Can can we like use the Wheatstone formula of this?
Wheatstone, Wheatstone formula is, yeah, we have used the Wheatstone idea, right?
Okay. Mm-hmm.
But Wheatstone formula is something like this one. R1 by R2 is equal to
Yeah, it's
R3
for
by R.
resistors.
That, yeah, that thing we are not using, right? That thing
Yeah.
we are not using. Only the thing is that in this
There's
part would
no.
not be part. Yeah,
Yeah.
this part would not be contributing, right? So yeah, this part we can discuss. Only that is the idea that we will use because there is no this is because this series connection would be different as in the case of the resistance one, right? We
Yes.
defined we defined that idea because that was this R1 and this R3, they were in series, so they had same current. But
Mm.
now this part is in a series, but the capacitance, overall capacitance, that would be different, right? So yeah, so that we cannot.
Okay, sir.
Okay, clear. Do you want to note this thing?
Uh,
Or
I, I will just write down the question.
yeah, yeah, just write down the question and then yeah, try this at your home, right? So the
Yes.
most important part is this diagram, right? This
Hmm.
diagram is very important. So if you from here, if you get this diagram, then that would be easy.
Yeah, I studied the electrical, so there were many questions this type.
Hmm. Oh, okay, good, good. Yeah. As soon as you have noted, please tell me.
Yes, sir. So done.
Yeah. Okay, so now let us quickly do this infinite series problem and then, yeah, few questions on the dielectric and then we'll move on to the fourth one. Okay, so the next question is this infinite series problem, right? So in this one, find the equivalent capacitor of the ladder, right? So this is the diagram, right? So it goes like this A, and this is 1 microfarad, and then this is B, right? And then this 2, and then again 1, and then something like this one, right? And so on. Right. So this is the infinite series problem. So if you look at this thing, right? If you look at this thing, so what is repeating always? What is repeating?
1 microcoulomb and like the
2, 1. Right. Absolutely
yeah.
correct. So this thing is always repeating. So if I consider this thing, if I let this capacitance as C, right?
Yes.
So if I cover this part, right? Let's say if I hide this part, so then again it is the same,
Yes.
right? So again it is the same. Then we can equivalently draw this one as and this is C, right?
Yes.
Because again this whole thing is repeating, right?
Yes, sir.
So then we can solve this thing. So if we go from here to here, right? This part is in series 2 and this C, right?
Yes.
So the effective capacitance would be 2C by 2 plus C, right?
Yes.
So, and now then we have two connections. One is 2C by 2 plus C, and then the other one, which is in parallel, that is 1 microfarad, right? So this is A, this is B, and this is 1 microfarad, right? Now these are
Yes.
in parallel, so and we can write this thing as 2C by 2 plus C plus
Plus
1,
one.
and that would be equal to what? What is the equivalent capacitance that we have assumed?
C.
It's C, right? It was C.
Yeah.
So this is the equivalent capacitance. And then if we take this thing in the other side, okay, let's take this thing. So this is 2C plus 2 plus C divided by 2 plus C into C. So this is 3C plus 2 divided by, not divided by, but 2C plus C square, right? So this all these things goes the other side. 2C minus 3C is minus C. So this is minus C minus 2 equals to 0. So if we solve this thing, so what would be C? C would be minus B, which is 1. So 1 plus minus B square. B square is 1 minus 4AC. So 4 to the 8, right? Divided by 2A. So this is 1 plus minus, this is root 9 is 3 divided by 2A. So 4 by 2 and minus, so minus would not be the answer. So this would be 2 only, right?
Yes.
So 2 microfarad. That is the capacitance, right? Clear?
Yes, sir.
Okay, then quickly note this one and then we'll do the other question.
Done, sir.
Done. Okay, so now
Yes.
let us do these dielectric questions and then we'll start the fourth one. Okay, so again, why do we have so yeah. So find the ratio of the capacitances of a capacitor filled with two dielectrics of same dimension but of dielectric K1 and K2 respectively. And yeah, so we have to find the ratio of this capacitance and this capacitance, right? Figure 1 and 2. And then the next question is, a capacitor is filled with two dielectrics of the same dimension but of dielectric, find the ratio of in two possible. So now they have given the value as well, right? So first diagram is this one. And the capacitor, the dielectric, they are like this, right? Now let us see that what kind of connection are there. So let's say this is positive. This is a negative, right? So you see that if you this is K1 and this is K2. So if you see this connection, right? If you see this connection, one capacitor positive, right? And then with the positive, again, the positive is connected. Something like this one, right? This
Hmm.
is A and this is B. So you see that this is positive. So positive is connected with positive, right?
Yes.
And negative is connected with negative. So what kind of connection is this one?
Something.
This one is a parallel connection, right?
Oh, yeah. Okay, you were asking that. I thought something else.
Yeah. So these are parallel connection, right? This is
Yes.
C1 and this is C2. So the overall capacitance, that would be C1. We'll talk about that later, but let us first calculate C1. So C1 would be, and you see that the area of this thing, right? The
Yes.
area of, let's say the total area is A. So this area would be A by 2, right? This area would be A by 2, right?
Yes.
And the distance is same, right? So distance remains the same. So if I calculate C1, can you tell me what would be C1?
A by 2, epsilon naught by D, something like that.
Yeah, A by 2. And now, because this is a dielectric, so that would be epsilon naught K1 by D, right?
Okay. Yes.
So this is A epsilon naught K1 by 2D, right? Similarly, we'll directly write C2, which is A epsilon naught K2 by 2D, right?
Yes.
And we know that the overall capacitance, that would be C1 plus C2, right? This is
Yes.
case. So this would be AE epsilon naught K1 by D plus AE epsilon naught K2 by 2D. And AE epsilon naught 2D is common. So we can take AE epsilon naught 2D common. This is K1 plus K2, right?
Yes.
So this is one case, and another case is this one. So you have a connection like this one. So this is something like this, and then the other one is this, right? So if let's say this is positive, this is a negative part, this is positive, and this is negative, right? This is like this connection, right? So you see that positive part and negative part, this is the capacitor. And then you see that negative is connected with positive, right?
Yes.
So this is positive, this is negative, positive, negative. So what kind of connection is this one?
Series.
Series one. And then in series C equivalent, because two capacitors are there, so that would be C1, C2 divided by C1 plus C2, right?
Yes.
So let us, and this is K1 and K2. So we already know what is K1 and K2. No, 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 no. This would be different, right? And now you see that area will remain the same, right? Area is A, but separation would be half,
D by 2D.
right?
Yeah.
Yeah. So now C1 would be A E epsilon naught K1 by D by 2, which is this 2 will go upstairs. So 2 AE epsilon naught K1 by D. C2 would be 2 AE epsilon naught K2 by D. Right.
Yes, sir.
So if we calculate the equivalent, so let's say this is C equivalent prime. So this would be C1 into C2, 2 epsilon naught K1 by D into 2 epsilon naught K2 by D divided by plus of this thing. So 2 epsilon naught D K1, 2 epsilon naught K2 by D. So we can take common in here, right? So 2 epsilon naught K1 by D and 2 epsilon naught K2 by D divided by 2 epsilon naught by D common, this is K1 plus K2, right? So this part and 2 epsilon naught by D cancel. So this is, so you have equivalent to epsilon naught by D and K1, K2 divided by K1 plus K2, right?
Yes.
Now we have to find, in the question they were asking that find the ratio of these two instances, right? So let us find the ratio. So C equivalent divided by C equivalent prime. So that would be uh, AE epsilon naught by 2D, AE epsilon naught by 2D K1 plus K2 divided by 2 AE epsilon naught by D K1, K2 divided by K1 plus K2, right?
Yes.
So AE epsilon naught cancels, D cancels, this 2 goes downstairs. So, and this K1 plus K2 goes upstairs. So it becomes K1 plus K2 whole square divided by 4 K1, K2. That would be the answer, right?
Yes.
And this is the first part. Second part, they were asking that if K1 is how much? K1 is 2, K2 is 3. So K1 is 2, K2 is 3. So then the ratio would be 2 plus 3 square divided by 4, 2 into 3. So how much is this thing? 2 plus 3, 5, 25, and then 6 day 24. So this would be the answer. Right. So is this question clear to you?
Yes, sir.
Okay, then please note down this thing. Yeah, whenever you want me to scroll down the screen, please tell me.
Okay, sir. So can you scroll down?
Yes, yes. Yeah, whenever you have noted, please tell.
Okay, so this one. Done, sir.
Done. Okay, so now
Yeah.
let us do the next question. Yeah, so the second one, the diagram is not correct, right? So we'll skip this one. Let us do the third and fourth one quickly. I will do, and yeah, only one type of question in this one we'll do, right? So then that would be done, right?
Hmm.
Yeah, so let us quickly do this third one. So again, we have, right, this is positive. So can you tell me what kind of connection is this one?
Parallel?
Parallel?
No,
No.
no. It's so
Yeah,
plus
so,
negative and then plus negative. Yeah.
yeah, so this is this one. And then we have this one. And then so, right. So, so this is plus, this is minus,
Yeah.
this is plus, this is minus, this is plus, and this is minus, right? So plus, minus, plus, minus, plus, minus, right? So series, right?
Yes, sir.
Now, with the distance is different, d by 3. D by 3 area would be same. All of them have same areas, right?
Yes.
And now, so this one is, I guess, what is the capacitance of this one? Um, Between the plate of area, copper plate side. Okay, so yeah, let's say this one has C3, right? C3 would be how much? C3 would be A epsilon
Epsilon.
naught, and I guess this is also K, right? 2. This is K divided by D by 3, right?
Yes.
And this one would be how much? So this would be 3A epsilon naught K by D. This is C3. C2 would be AE epsilon naught and K of copper, right? D by 3. So this would be 3 again AE epsilon naught dielectric of copper divided by D, and C3, C1. This is again 3 AE epsilon naught K by D. Both have same dielectric, right? Same color, so their dielectric is same. This is also K by D, right?
Yes.
Now, all of these connections are in series. So equivalent capacitance would be this one, right?
Yes.
So 1 by C equivalent would be, this would be D by, let me write it as D by 3 A epsilon naught, right?
Yeah.
This is D by 3 AE epsilon naught K copper, D by AE epsilon naught K. So what is K of copper? What is the dielectrics of a metal?
Mm, was something 1 point or
Infinity, right?
infinity? Mm, I
So
don't.
this thing, yeah. So yes, yes. Any, yeah, metal has infinite dielectric, right?
Yeah.
So this thing is something by infinity. Something by infinity is how much?
Infinity.
One, and then you divide it with a very big quantity, very big quantity. You have one chocolate, and then you have thousands of people, right? So if you divide that chocolate, then one person will get how much chocolate? Nearly zero chocolate, right?
Yeah. Yeah.
Yeah, so you have one, and then you are dividing with, let's say, one divided by 100,000. So that would be 0.0000. You see, this is nearly zero, right?
Yes.
So this part is zero, right? Let me write it as that something by uh, d by infinity. So this is zero, and then this is d by 3 ae epsilon naught k. So this would be 1 by C equivalent, and then 2D divided by 3 AE epsilon naught and K. So C equivalent would be 3 AE epsilon naught K by 2D. Right. So K they have given, that is 2 by 2D. So 2 and 2 cancel, and this is 3 AE epsilon naught by D. Clear? Where is here? This one. Is it clear?
Yes, sir.
Okay, then please note it down. And the fourth question, I will leave it to you. Right.
Okay.
Please try this question at your home, and then much time. Oh, it's already 8. So I will do one more question from this one, and then I'll start the fourth chapter.
Okay. Sir, I completed.
Done. Okay, so
Yeah.
let us do the next question, right?
So my mom is calling. Can I be back in 2 minutes, sir?
Yes.
Can I be back in 2 minutes?
Yes, yes, yes. Sure, sure, sure. Of course, yes.
Yes, sir.
Done.
Yes.
Okay. Okay, so now let us, I will give you the hint of this question and then we will move on to this fifth one, right? So in this one, right, it is divided in two parts. This one and this one has area A by 2. This one has area A by 2, right? This part is, let's say this is plus, 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 right? This is minus, minus. And in here again, we have minus and plus, right? So first we
Yes.
have to solve this K2 and K3. So C2 and C3, they are what?
Series.
Series, right? And then whatever this C23 is, then C1 and C23 are parallel,
Salad.
right? So that you have to solve, right? So yeah, this is your homework. You solve this question at your home. And if you face any, you just note down the question, right?
Okay, sir.
So tomorrow I will ask, right?
Okay. Done, sir.
Done. Okay, so now let us do this next one, fifth one, and then we'll skip, right? So yeah, then I will all these questions. Yeah, you try at your home, and yeah, we will talk about this question. Okay, so let's do this last one, and then we'll start the next one. So what is the capacitance of arrangement of four plates of area A at a distance? So this is P, right? And they are connected like this. This is Q, right? And this is something like this one. And this separation is D, right? This separation is also D, this separation is also D. So everything is D. So let's say if P is connected to positive, so this would be positive, right? And then you have this is connected to positive, right? This is connected to negative, so this is your negative part. And then this is your negative part, right? So how many capacitors do we have?
Two.
Two, right? So this one and this one, right?
Yes, sir.
And you see that positive ones are connected together. So positive ones are connected together and negative ones are connected together.
Parallel.
Right. So what kind of connection? So this is a parallel combination, right? And
Yes,
all
sir.
of them have same area. So then C would be C1 plus C2 simply. So C would be AE epsilon naught by D plus AE epsilon naught by D. So C would be 2 AE epsilon naught by D. Right. Clear?
Yes, sir.
Okay, then please note down this one and we will do the next one.
Done, sir.
Done. Okay,
Yes.
so now this question again, I will leave it to you, right? And now we can start the fourth chapter. Okay, so this one will be what? This is positive, and this is negative. This is positive. This is negative, right? So how many capacitors do we have?
2.
You see one. This
Okay, yeah,
is
3. Yeah.
three capacitors, right?
Yes.
And how they are, yeah. So how they are connected. So you see that all the positive ones are connected together, right? And all the negative ones are connected together. So again, a parallel combination, right? Yeah. So and so this would be again C1, C2, C3, and this is 3 AE epsilon naught by D, right? So that would be the answer. Okay, so we'll leave this part, and now these are some miscellaneous circuits. So switch is closed and switch is open. Then you have to find out the potential difference and charge and all these things, right? So energies and all those things. So that this part I will leave it to you, and now we can do all those. Yeah. So now everything is done, right? Okay. So now let's start the new chapter. What is this? Current that you have done with now. So new chapter is magnetic, moving charges and magnetic field, right? So in the previous two chapters, first two chapters, the charges were stationary, right? And
Yes.
then in the third chapter, we saw that charges were moving, and then now we'll understand that if charges are moving, then it will create some magnetic field, right? So because of the current, you will have some magnetic field. And mainly, right? Oh, what is happening? Why it is not clicking? Okay, so let me close this thing. Okay, so now let us talk about magnetic field. So in the first chapter, we had a law about the charge, right? Remember, do you remember? For a charge, there was a law. What was the law?
The electrostatics law, when the two charges are
Yeah,
separated by
Coulomb's law, right?
K, yeah, K3
So,
over epsilon.
yeah. So similarly, in here we have a law for magnetic field, and that is Biot-Savart's law, right?
Sir, your that whiteboard is
Yes.
not visible.
Oh, I have not shared. Oh, I have
Yeah,
not shared. Hmm. Okay, okay, let me share it. Yeah. So Biot-Savart's law, right? So what does it say? So it says that if you have a wire and it is carrying a current, right? This is carrying a current. Let's say the current is I, and then you take some small portion of this thing, right? Let's say this is DL, right? And then you measure let's say you are measuring the magnetic field at this point, right? So this is the distance R, and this is DL, and this is the angle between the DL and R, right? And you are calculating the magnetic field at this point. So due to DL, there would be some small magnetic field dP, right? And the amount of magnetic field this will have would be IDL and sine theta divide mu naught by 4 pi and then divided by r square. So this is the Biot-Savart's law, right? That you already know. And if we
Yes.
write it in vector form, so this would be mu naught by 4 pi and I dl cross r divided by r cube, right? So this is the vector form, and the direction of magnetic field would be, how do we get the direction of magnetic field? Yes, how do we get the direction of magnetic field? So cross product, right? You put your palm in the direction of DL, right?
Yes.
And then you cross your finger in the direction of R.
Yeah.
So whatever,
Now I
whatever,
remember.
whatever direction your thumb is pointing out, so that would be. So in this case, the direction of magnetic field would be inwards, right?
Yes.
And how do you represent inward direction? You represent it with cross, right? Clear?
Yes, sir.
Okay, so using this law, we calculate the magnetic field of different kind of things. And mainly, we have two kinds of wire. One is straight wire, right? And the other one is circular wire. Right, so straight wire again is of two kinds. One is infinite and the other one is semi-infinite. Right. Circular wire is three kinds. One is, yeah, again, full circle. The other one is semicircle. And the other one is R. Right. So infinite wire has magnetic field mu naught I by 2 pi R. Right. This one has magnetic field mu naught I by 4 pi R. Right. This one has magnetic field mu naught I by 2R. This one has magnetic field mu naught I by 4 pi R. And this one has magnetic field mu naught I by 4 pi R. And this one has theta, right? So how do you, so let's say this is DL, right? And then this is R. So you have, and this is your theta, right? So then this, if you solve this thing, IDL And dl cross r would be dl and r, right? And then sine theta. So if we take, right, this is theta and dl cross r, and we have to, right? So how do you get that thing? So this is, right? So let's say if it is dl, right? And you integrate this dl. So this would be, magnetic field would be idl, and sine theta is 90, so that is 1, and divided by r square mu naught by 4 pi. You integrate this thing, so you have to only integrate this dl, right?
Hmm.
So mu naught I by 4 pi r square, you integrate this dl. If you integrate it, now for full circle, that would be 2 pi r, so that is okay. But for arc, this would be this length, right? Let's say this is L, arc of L. So this would be mu naught I by 4 pi r, and then this L, right? And how do you calculate the arc length? So arc length is theta
Theta by
by 360 into 2 pi r. Remember, this theta is in,
degree.
degree, right? So yeah, so that is how you calculate this thing. So this would be mu naught I by 4 pi r, and then theta into 2 pi r divided by 360. So 2 pi r, and then this is 2. So this is mu naught I theta by 720 degree, right? But if it is in radian, then theta is L by R. So L is simply R theta, right? If it is in radian. So if it is in radian, then this thing would be how much? So if it is in radian, then this would be only in, yeah, this would be mu naught I by 4 pi R, and then this is R theta. So R and R cancel. So this is mu naught I theta by 4 pi. This is the answer, right? If it is in radian. So mu
Okay.
naught by 4 pi r. Yeah, this is only theta if it is in radian, and if it is in degree, so this would be mu naught I by 720, and then I theta, right? So these are the things that you have to remember. Okay, here theta is in degree, right? So yeah, these are the things that we have to solve. So please note down this thing, and then we'll solve the question in the next class. So you have to remember all these things, right? All these things you have
Okay,
to
sir.
remember. You take a screenshot, right? Take a screen. And if you want the derivation, then we'll derive this thing in the, yeah. So because I don't want to get into the derivation, that will take some time. So I will just want to solve the questions. But if you want the derivation, please don't hesitate.